Let's look at a common piecewise function in mathematics called the absolute value function, which can be defined as the absolute value of x is equal to x if x is greater than or equal to 0, or negative x if x is less than 0. Let's sketch the graph of this function. If my input is 0, then my output would be 0. If my input was 1, then my output would be positive 1. If my input was positive 2, then my output would be positive 2. And if I continued on, it would form a line like that. And then if I plugged in negative 1, my output would be positive 1. If I plugged in negative 2, I would multiply that by negative 1 to get positive 2, and my graph would look something like that. So essentially, when we graph the absolute value function, it looks like the letter V. Example 10 says, consider the function f of x equals the absolute value of x. We want to evaluate the following. F of 100 is equal to the absolute value of 100. Since 100 is a positive number, the output will just be 100. If we're evaluating f of negative 8, that would be the absolute value of negative 8, which is, because negative 8 is a negative number, we would multiply negative 8 times negative 1, and that would give us positive 8. Same thing with the absolute value of negative 3/4. That is going to give us a value of positive 3/4. So as you can see from these values that we've taken into account, as well as the graph, our output values are always going to be positive or 0 when we're dealing with the absolute value function. The difference quotient is a very important topic to understand in preparation for calculus. If you have a function f of x, then the difference quotient is given by the expression f of x plus h minus f of x over h. There are many variations to this formula, but this is the one that we will work with. Another common variation is f of a plus h minus f of a all over h. So there's a variation, but again, this is the one that we will be commonly working with. Example 11 says find the difference quotient for the following functions. In part A, we have f of x is equal to 5x minus 2. Now, before we write out the difference quotient, I'm going to suggest that we evaluate f of x plus h. So the way that we do that is anywhere we see an x in the function, we're going to replace it with x plus h. So I have 5 times, instead of x, I'm going to write x plus h minus 2. Now what we're going to do is I'm going to write the formula for the difference quotient, which is f of x plus h minus f of x all over h. And I'm going to highlight some things. So f of x plus h I have here, and that is this expression here. So in fact, we've rewritten f of x plus h so that it's just this expression here. And then f of x, we're going to end up subtracting that, and that is here equal to 5x minus 2. So let's go ahead and do some replacement. I'm going to replace f of x plus h with 5x plus h minus 2. And then I have minus, and now I'm going to subtract off my original function. But I need to make sure that I include either parentheses or brackets because I'm subtracting off the entire thing. And then this is all being divided by h. So again, let me emphasize, this is f of x plus h, and this is f of x, our original function. Now, what I would like to do is I want to simplify this, and the way that I'm going to do that is I'm going to simplify the numerator. If I distribute in the 5, then I'm going to have 5x plus 5h minus 2, and then I'm also going to distribute in this negative sign, and that would give me minus 5x plus 2 all over h. Now, when you're doing difference quotient questions, one clue that you are on the right track and taking the right steps is that everything that is in the numerator that does not have an h in it should be somehow canceled out. What do I mean by that? Well, let's combine like terms. I have a 5x minus 5x and a negative 2 plus 2. Adding those results in 0. So now what we're going to have is we are left with 5h in the numerator over h. And what ends up happening is the h in the denominator should end up dividing out. So these will divide out, and my final answer that I'm left with is 5. Okay, let's work on part b now, which gives us the function j of x is equal to negative 4 plus 6x squared. Now, coming back over here, I'm going to replace these f's because our function is now called j. So I'm going to think about j of x and j of x plus h. So j of x is equal to negative 4 plus 6x squared. And j of x plus h is the same thing, but now I'm replacing x with x plus h. So I'm going to highlight this in yellow like I did before. And then I'll highlight this in blue. Now, if I want the formula for the difference quotient, instead of having f, I'm going to write j because that's our function name. So our difference quotient is going to be j of x plus h minus j of x all over h. And j of x plus h is in yellow, and j of x is in blue. So now we have that this is equal to negative 4 plus 6 times x plus h quantity squared, and then I'm going to subtract off the original function. So minus negative 4 plus 6x squared. And then this is all over h. So let's do some more highlighting again. Here is j of x plus h, and then in blue I am highlighting j of x, our original function. Now we want to simplify the numerator, and hopefully everything that does not have an h in the numerator is going to cancel out so that eventually we can divide by h and no longer have a fraction. How do I simplify this? Well, if I'm following order of operations, I need to do the exponent first, and I need to multiply x plus h times x plus h. I'm going to use the box method to do that. So I have x plus h times x plus h. Now I can multiply accordingly. X times x is x squared, x times h is xh, x times h is xh, and h times h is h squared. Now notice in the diagonal here, these are both like terms, so if I add them, this is going to end up giving me x squared plus 2xh plus h squared. So my numerator is going to be negative 4 plus 6 times x squared plus 2xh plus h squared. And I'm going to distribute in my negative sign here, so I'm going to distribute that in. That's going to give me plus 4 minus 6x squared. And this is all over h. Now what I can do is I can start to distribute this 6 in. And if I do that, we get negative 4 plus 6x squared plus 12xh plus 6h squared plus 4 minus 6x squared all over h. Let's do some simplification in the numerator. Negative 4 plus 4 is 0. 6x squared minus 6x squared also will give us 0. And now we can see that we'll be left with 12xh plus 6h squared all over h. And both terms in the numerator have an h, so what I can do is I can factor out an h. And now I have the ability to divide this h with this h, and so my final answer is going to end up being 12x plus 6h. Example 12 wants us to find the difference quotient for the following functions. In part A, we have p of x is equal to negative x squared minus x plus 7. So we want to find p of x. I'll just copy down my function again. And then we will also want p of x plus h. That's going to end up equaling negative x plus h squared minus x plus h plus 7. Let's go ahead and write the formula for the difference quotient here. We have p of x plus h minus p of x all over h. So here we have p of x plus h, and here we have p of x. Let's go ahead and say that that is equal to negative x plus h quantity squared minus x plus h plus 7. Then we have minus our original function, and don't forget to put brackets or parentheses. And this is all over h. Now, in the numerator, negative quantity x plus h squared, we've already expanded x plus h squared, so I'm just going to go ahead and rewrite that from the previous example. I was starting to run out of space, so I rewrote this. Now I'm going to distribute in the minus sign here. So I'm going to have minus x minus h plus 7. I'm also going to distribute this minus sign. So that's going to give me plus x squared plus x minus 7 all over h. And now what I can do is I can distribute this negative sign in. And if we do that, I'm going to erase this and get rid of the brackets. So this is going to be negative x squared minus 2xh minus h squared. Let's see if we can't do some cancellation. So I have x squared minus x squared, x minus x, 7 minus 7. And it does look like everything else remaining has an h in it, so we're probably on the right track. So every term has an h in the numerator. I'm going to factor out an h in the numerator. That's going to leave us with negative 2x minus h minus 1 all over h. Now these h's will divide out, and we are left with negative 2x minus h minus 1. And there's our final answer for part A. All right, so for part B, we have f of t is equal to 1 over 2t plus 9. I went ahead and I rewrote f of t, and I also wrote f of t plus h. Now in my next step, I'm going to distribute this 2 in and rewrite this as 1 over 2t plus 2h plus 9. So now let's write the expression for the difference quotient, which is f of t plus h minus f of t all over h. F of t plus h is this thing here, and then f of t is this. So I have 1 over 2t plus 2h plus 9 minus 1 over 2t plus 9 all over h. Now, how are we going to deal with this? Because this is quite a complex fraction. Well, in the numerator, I want to find a common denominator. So I'm going to multiply this by 2t plus 2h plus 9. And then this fraction, I'm going to multiply by 2t plus 9 over 2t plus 9. And if I do that, that's going to give me a common denominator. And in my denominator, I'm going to have 2t plus 9 times 2t plus 2h plus 9. Now, you might have an inclination to multiply that out, but you can actually just leave it like that and make your life a lot easier. I do want to multiply 2t plus 9 times 1, so I'm multiplying this thing, and that's just going to give me 2t plus 9. Then I have this minus here, so minus, and then multiplying 1 times that 2t plus 2h plus 9 will just return that. So I have 2t plus 2h plus 9. Please do not forget your brackets, and then at the denominator I have an h. Let's go ahead and distribute this minus sign. That's going to give us 2t plus 9 minus 2t minus 2h minus 9 over 2t plus 9 times 2t plus 2h plus 9 all over h. What's going to happen now? Well, this 2t minus 2t and 9 minus 9 become 0. Now we'll be left with negative 2h over 2t plus 9 times 2t plus 2h plus 9. And then in the denominator, I have an h over 1. And the way that we deal with complex fractions is we keep, change, flip. And what we're going to do is we're going to multiply by the reciprocal of the denominator. Now what happens is I have an h in the numerator and an h in the denominator. And then this is going to become and simplify to negative 2 over 2t plus 9 times 2t plus 2h plus 9. And here is our final answer. Again, you do not need to multiply out the denominator. You do not need to expand it. This is sufficient as a final answer. Let's talk about the vertical line test, which says a graph is the graph of a function if and only if there is no vertical line that crosses the graph more than once. Example 13 says determine which of the graphs shown below are graphs of functions. In part A, this is the graph of what we call an ellipse. And if I draw a vertical line, it would intersect my graph at more than once or more than one location. So this tells us that this is not a function, and I'm going to abbreviate function with fxn. So this is not a function. Here in part B, any vertical line I draw will only intersect the graph at most one place, and therefore this is a function. So is a function, it passes the vertical line test. And then in part C, we have the Batman symbol. If I drew a vertical line, it would intersect at more than one place. So this is not a function. And that is a quick summary of the vertical line test. An x-intercept is the location where a graph crosses the x-axis or the horizontal axis. A y-intercept is the location where a graph crosses the y-axis or the vertical axis. Typically, intercepts are presented as ordered pairs. A 0 or root is an input value that makes a function's output value 0. A 0 or root is also the x-coordinate of an x-intercept. Example 14 says graph the following functions, identify any intercepts and zeros. In part A, we have y equals negative 3x plus 2, which is a linear function. From the linear function, which is in the form y equals mx plus b, I know that the y-intercept is 0, 2, and I know that the slope is negative 3, which tells me rise over run. So I can go down 3 units and write 1 unit, down 3 units, write 1 unit, down 3 units, write 1 unit, and now I can connect that with a line. Now that we have the graph, let's talk about any intercepts. So the x-intercept is going to be this point right here where it crosses the x-axis. Now, because that's not going through a grid line, I don't know exactly where that is, but the way that we can figure that out is I know at this coordinate right here that the y-coordinate is 0. So if I, in my equation, set y equal to 0, I can solve for x by subtracting 2 on both sides. I get negative 2 equals negative 3x. Then if I divide both sides by negative 3, we get x equals 2/3. So this is 2/3. My x-intercept is 2/3, 0. My y-intercept, we know that it's 0, b, and b in this case is 2. And then my zeros, or 0 in this case, because we're just singular, is x equals 2/3. So those are the requested values for part A. For part B, we have g of x equals x squared minus 2x. This is a quadratic function. And what I can do is I can factor out an x, which would leave me with x times x minus 2. If I wanted to solve for the x-intercepts or the zeros, I could set this equal to 0, then use the zero product principle and set each of these factors equal to 0. So I'd get x equals 0 and x equals 2. That tells me my x-intercepts are at 0, 0, and 2, 0. I know that because my a value is 1, or my leading coefficient is positive, that this is an upward-facing parabola. I went ahead and I plotted some ordered pairs that fall on the graph by plugging in values like 1, 3, and -1. So I got some ordered pairs and I connected the dots to create the graph of my parabola. Let's identify the intercepts now. So my x-intercepts are at 0, 0, and 2, 0. My y-intercept is also at 0, 0, and then my zeros are 0 and 2. I'm just going to place them inside of curly brackets to denote that that's a set and it's just those two elements. And there is the answer for example 14.